All right, so this is our first online lesson for automated manufacturing systems. You have just now, you should have watched the videos that I recommended, and now what we need to do is do some of the theory work. So what I would like you to do is have open your textbook and have the heading characteristics of automated manufacturing systems already written down. You should be taking notes while I'm talking, and I'm going to present the information using this Prezi. While we're talking about this, it's important that you understand the three videos that you watched about steam, industrial revolution, and the two examples of automated manufacturing plants. You need to be aware of what happened in those videos, and because I'll keep referring back to them. So the first thing is we need to realise is that in automated manufacturing systems, there are not only with the invention of steam, but also the creation of robots and robot arms and things like that is important to understand that helps with the automated manufacturing system. So like it says in your textbook, without these types of systems, we wouldn't have much automation going on. So what do we do in them? We have inventory tracking. Now, inventory tracking is a classic example of that is barcode reader systems, where in an automated system, you can read the barcode and using a scanner and keep some sort of inventory control as to where in which your inventory is going, or where it is stored, or how much you actually have. So obviously, in our studies of databases, we understand that you can put in items and you can keep records of what we have, and that can be updated by using barcode scanners quite easily. They also are really good for record keeping in automated manufacturing systems. So a classic example is this is a mail room system or a library system where everything's inventory tracked, and this lady's obviously taking something like a post-it note or something out, and she's now changing the dial to say that there is now less than 9 or possibly 9 in the box that she has there, and she's going to make sure that that's done properly. Then we have things like production scheduling, and production scheduling is a lucrative business actually. This is where when a product is being built, you can see here this looks like a motor of some sort. Could be anything. It could be a motor in a washing machine or whatever. The production line assembly actually does come down and comes to a person, or it's going the other way, and they are required to actually place the components on, and then the next person does their additions to that. And this is done in assembly line production. So as you can see, there is a number of people employed to actually design production line assemblies. I actually, one of my mates, his job is to actually do this, and he travels all over the world doing designing of production line assemblies. Now, of course, a automated manufacturing system does what's known as tasks, and they can simplify the process of what needs to be done for the participants, and we'll get into that very shortly. Not only that, they also collect data, and the data that they collect is based on what sort of ways you can collect data. So taking the analog signals from the environment and making a decision with that. So these are the types of things that are going to be used to collect data. And each of these we will be going through in this course to understand them. You can see there's a pressure gauge. So what is it actually? Is it a pressure gauge or is it a flow gauge where it's taking readings from pressure? It might be steam, could be just simply the flow of a liquid, a hydraulic or whatever, using a pump. These over here are temperature, different types of temperature sensors. And what are they doing? Are they thermocoupling temperature sensors where two metals are joined together and one expands more than the other and consequently turns on or off a switch? This symbol here represents a laser, so we see that they're going to be barcode readers, and or they're just simply going to know that an object has gone past it, and then they're going to make a decision about that. Over here we might have, say, flow sensors, or even just what's known as actuators or motors. And of course, that's a barcode reader in its rawest state, really. So we're going to learn how these all work. We're going to learn what they're used for, why they do things, and then make decisions about when you would use them in a certain situation. The next one here is, of course, they process data. So once the data has been taken by the environment, the inputs comes in from the environment, can be anything, then that data has to be processed. And what we mean by process in this situation is we have to make a decision. And I've got a picture here of a NXT Lego Mindstorms. And this brain here, they're quite, this whole kit here is, quite expensive. We're talking about, $500-$600 for this kit. And they're now called EV3, so they're not an NXT device. But this brain, it takes input from the environment and makes a decision about it, but it also outputs as well. So, for example, here, this is a push sensor, right? And in automated manufacturing systems, we might have a push sensor that knows that a box has come to a certain part of the factory, and then it has to make a decision about where it's going to go next. This one here is a sound sensor, so effectively this device can listen to something and make a decision. So I used to program these to, when it heard a clap, then it would walk. Or this one here is a ultrasonic sensor where it actually detects motion. So if, for example, this was walking towards a wall and it got to a certain distance, this would then say, well, I'm at a wall or I'm at an object. I need to back up a little bit or stop walking, back up a little bit, and then turn. It also has the other ones like light sensors as well, but we'll learn a lot about sensors in this subject. Now, I'm not sure whether this is going to work, but the first definition of terms of things that we're going to learn about in the characteristics of an automated manufacturing system is what an actuator is. And actuators are really cool. Another name for an actuator is a motor. And actuators, I think, one of the coolest things about automated manufacturing systems, because you are able to have motors and use them in certain ways. Now, I normally, if we were in the classroom, what I would do is I would have an example of a motor and I would show you how it works. But in this case, I do have a little video here on how a motor works. And what I'm going to do is I'm just going to see if I can just get the... you guys can watch this anytime, but I'm just going to pause it here and just explain this to you so that you don't have to watch this video. Now, this is simply how a motor works, where what we have is power, so the battery is here, and you can look this video up on YouTube if you want and watch it at another time. But it works with a magnet and power, and then we have an area of rotation, all right? And we then have wires which we use to actually produce the rotation. Now, I just want to say this, that a lot of students, when they do study information processes and technology, tend to study physics as well. And in physics, you do learn about different types of motors. Now, the types of motors that we are looking at mainly in automation is, not only just actuators or motors that spin, but we also have ones that know how to generate power, and also ones that actually are called stepper motors, and I'll get into how they work as well. But the interesting thing about this is that when we add power to this, what happens is the electrons flow here and need to then flow into this part and get out here and then go back. So we know that that's why something's called a circuit, is because that it's going around in a circuit. But when we add power to this one, an amazing thing's happen, is that it actually forms, this actually, when the power comes into here, it actually forms a electromagnet, and the resulting effect of this being an electromagnet is that this magnet here is attracted and opposed to it. Just like if you grabbed two magnets, which I'm sure you've done in a science experiment where a teacher's handed you some magnets and you tried to push them together, and they jump away from each other because you probably got the two norths together or the two souths of the magnet together, and they are unattracted to each other. This works in the same way as that, but also in the reverse of that, where they're positively attracted to each other and then negatively opposed to each other as well, as soon as the power runs. So that's why you have this thing called a commutator in here, which and also the brushes. The power is actually transferred into this part, but then when that spins, it then has to go to the negative part. So there's a little gap here. So this piece of metal is has a gap because it needs to go to the bottom as soon as it starts rotating. If it was joined, this would just go boom and just move to one location and stop. All right? But because it's going plus, negative, plus, negative, plus, negative, when it spins, it then goes plus, negative on this bit and gets it opposed. Now, the more power you add to it, so the bigger the battery, the faster this will spin. All right? And also the more what we call torque, or the more power it will have as well. And they're very effective. And in fact, if I try and go back to this one here, these grey plastic in here that you see here and that orange bit, these are the motors of a NXT Lego, right? And they are super efficient, right? So if I Google that Lego NXT motor and get an image of it, if I just get it, this one here is that's fine. This here is a super efficient motor. So all that stuff that I'm talking about is happening in here so that this will spin. So there's a little drive chain in here that spins. And I've got one of these and I've pulled it apart just to show how efficient these are. Funny enough, the power comes in through the back. Maybe I might be able to show you that. Yeah, see, the power comes in here using an RJ11 connector, but it is highly efficient. Oh, there you go. Someone's pulled one apart and shown you the motor. In fact, they're so efficient that what you can do is get a cable, and I might be able to show you them connected. There's the cable there on this one. And if you connect that to the other end, that cable on the other end to another motor, when you spin that motor, that one that's connected on the other end actually spins as well. So they are highly efficient motors for the NXT. right? So that's what an actuator is, right? So we'll go back to where I was talking about it, right? And you can see the magnetic field is being connected. Now, if you're studying physics, the physics course, they actually ask you to learn this formula so that you can work out the direction that a motor is going to spin. In automated manufacturing systems and IPT, they just simply ask you to know how a motor works. So you're going to learn how to use a motor. There's two main types. There's one, just a simple motor, right? A DC motor, which is direct current motor. And then there's one called a stepper motor. And stepper motors are really important in automated manufacturing systems, and we're going to learn how they work as well. The next point that we need to make is we need to understand who are the direct users of a business in automated manufacturing systems. So there is a chart here, and this here is taken from the textbook, and it is a chart called an organizational chart. So, and it's hierarchical. So it's a hierarchical organizational chart where it shows all the users of a company, all the direct users of a company. So at the top, you have the shareholders, and then of course the shareholders are governed. They govern what the board of directors do make. So you have a board of directors, and usually you have a chairman, and then you have directors on the board. Underneath them is what's known as a managing director or a CEO, which is a chief executive officer. All right, and you would probably have understand many. You would understand who chief executive officers or people. You would know the names of some of them. It took me a while to just get my words out, but let's say, for example, the currently in 2020. If you're watching this in 2020, we've just had the COVID crisis, and the CEO of the National Rugby League was just recently sacked, and the board of directors, the chairman of the board of directors, he actually had to state why he lost his job and moved on and things like that. Then underneath that, in a business, we have all the managers, right? And of course, underneath them, we have like the second tiered managers. Then we have the supervisors who carry out the what the directives from the top down give, and then of course then there are the operators. Now, in a school, in our school environment, it's in the Catholic system we don't necessarily have these sort of things, but we do have managing director or a head, and then we have like these would be like the principals, and then we'd have like the leaders of learning, and maybe underneath them we might have supervisors, and then of course we have the teachers. So you can see this is where I am down here. All right. Now we talk about who's in control of all of that. Now, the reality is that the board of directors and the managing director and all these people are doing things for the shareholders because they're the ones that are investing in the company. So that's important that you know who's actually in control. And there's some notes in the textbook that you can take down about who's in control, things like that. And then, of course, you can see there's an image of a supervisor making sure that his workers are doing the right thing, and he's probably got some forms to fill out to make sure that they're meeting the needs of the company, or what we call the KPIs, the key performance indicators of maybe he's got to do this guy's got to have 300 boxes assembled per hour or something like that, and he's just making sure that he's doing his job and encouraging him to keep going and things like that. Now, the other thing that we need to learn straight off the bat is what's known as block diagrams, and I've screenshotted some of the textbook. And block diagrams are a little bit different to what you've learned as far as context diagrams and data flow diagrams. These, they really, really are simple, right? And they are very straightforward. Okay, so the symbols that you have here are a circle with an eye means that there's some input, and usually this is a physical part, right? And then you have what's happening. Like, let's say this would be the process that's happening. Now, it's a square, not a circle, like what a context diagram or a data flow diagram is. All right, so this is like just like an external entity in a context diagram or data flow diagram, except now it's probably going to be in the middle, and you can see down the bottom here where I'm moving my mouse that it's down in the middle of this one. And obviously O stands for output, and this is a usually a component, and most of the time it is a component, but then sometimes you'll have an input and an output like this one here as well. So you need to learn the symbols, and you need to learn what they do. So for example, here is the manufacture of a computer, right? So just a PC with its casing and things like that. So what you have is the inputs are the computer parts, then the process is assembling the parts, and then the output is, hey, look at this, we've got a computer built, all right? And then it can get quite complicated because what you do is you say, right, here is all the subsystems inside that system, and to develop the system unit. So we have the casing, we start with the casing. And then we need to go get the motherboard, and we insert the motherboard. That's the system, right? Then the input becomes the output, and then it goes, the next part is get the hard drive and insert the hard drive. So that's the system or the process in a square. Then we move on, and we've got those two already assembled, the motherboard and the hard drive, and then it goes along in this assembly line, and it says insert DVD drive, and you get the DVD drive and insert, and then the output is the system unit. Now, talking about HSC and questions that get asked, in automated manufacturing systems, what I've found is that they tell you all the parts that you need, or they might have one missing, and you have to either label the block diagram, or you have to draw a block diagram that assembles something. It could be anything really, it could be just a motor, for example. But the problem is that with the motor, they would actually give you all the parts that you need to do. So that's what a block diagram is, and that is the end of 6.1, the characteristics of an automated manufacturing system. I'm going to have some questions put up. I'm going to put them into the our OneNote, and you guys are expected to answer those questions after you have taken some notes about 6.1. Cheers, guys.